Welcome back, guys. In this video we are going to make a project, IoT based project, which will be on Aerial Link. What is Aerial Link and why we are going to make it? So basically the objective of this simulation is to solve a complex connectivity challenge, establishing a secure biconditional data link between a fixed ground headquarters and a mobile airborne warning and control system, also known as AWACS. So basically, if you are a student who has any interest in military analysis and how the modern weaponry is being used, so then you could uh, figure out that what this project is about and what it is going to do. But we are going to make it simple and start from zero. Okay, so now we are in our packet tracer and we are going to build it from scratch. So this is not just about connecting cables, we will be implementing a full stack solution. So first of all, we will start making our ground-based headquarters. So what devices it require? The first thing that it require is a router, and we are going to use 43331 router as a ground headquarter. Okay, so here it is, and we are going to give its name. Naming convention will make it super easy for us to remember that what we have done and what we are going to do. Otherwise, we will get confused. Okay, so we are taking here a router. Now, the question may arise that why we are using a router. So basically, in networking, a router is a layer 3 device. Means it is the only device capable of making decisions about where to send traffic outside of our local network. So without this router, our headquarter is just an isolated island. Okay. Okay, now moving forward, we need a switch. So I'm going to use 2960. Here it is, and change the name according to our project. Now the router handles the outside world. Okay, so to handle the inside world, we need something else. That's why we are using switch here. It creates a local area network LAN, allowing our computers to talk to each other efficiently. Okay, but now we need some end device because that would be something that will monitor the data. Okay, so we usually use PCs for that purpose. That's why I'm using a PC here. Again, renaming it. And we need a server. Renaming it. What server is going to do, it will basically host our data. Okay, now we have four devices. One is router, one is switch, one is monitor, and one is server. But now these all are isolated ones. They have no connection, they have no knowledge, they have no link with each other. So in order to build connections, we will connect them with each other. For this purpose, we are going to use our copper straight through cable. Okay, so I'm going to use it here, connect a router with switch. You could connect them with any port. And now I will name them because naming is very important. Just a minor correction here. It is not to connect with fast Ethernet. It will slow down. Basically, otherwise there is no difference. But it would be better to go at max right now. Gigabit Ethernet 0 by 0 by 0, and naming it same here to 0 by 1. Now connecting the switch with our server. Naming convention again, fast Ethernet 0 by 2 and fast Ethernet 0. And now also connecting switch with our monitor, our PC. Okay, done. Now what we have done here is that basically we have built our ground-based headquarter and we have connected all the devices that we have used. Now you are seeing here that this wire that we have used to connect ground headquarter switch and ground headquarter monitor, this is showing green signals here. It means that this connection has been established successfully. Also here between switch and server, the same thing. There are green lights indicating that the connection has been established successfully. But here between router and switch, the connection has not been established yet because there is an issue of IP addressing. We are going to solve this problem later. Okay, so now we have completed our ground-based headquarter, and now we will move towards our Skylink. What is happening there in air? For that, we need two fighter jets and we need one AWACS. Now, the AWACS, and as we know that we are going to make an IoT based project, so we literally need something that is means that is going to establish network with fighter jets wirelessly. So for that, we are going to use here in section of wireless devices WRT300N router, and we will name it AWACS. Note or plain, whatever you want. And we need two fighter jets. For that, we will use laptop here. Fighter jet 1 and fighter jet 2. Okay, so what we have done here is that we have completed our ground-based headquarter devices completely in terms of the requirement number, and we have done the very same thing for our Skylink or Skyline in the atmosphere where we need an AWACS and a couple of fighter jets. Okay, now still we have hardware limitation. Okay, so now what we are going to do. Okay, so here might arise the question that I am using here laptops to represent the fighter jets. Then means why I am using them? What is the connection with our project? Okay, so in the context of this IoT simulation, these laptops are going to function as headless IoT nodes. Means they will represent the embedded avionics systems inside the aircraft. If you know aircraft, fighter jets, fighter jet consists of avionics system. So this will create a classic IoT architecture. First of all, it will comprise of the perception layer, like these fighter jets will collect data, sensor data, and then it will consist of network layer. This AVAC, which is the this AVAC is the part of which the AVAX and router transmitting that data. This router and this AVAX will transmit that data, and then it is the application layer, means the ground server. This server will visualize that data, and then it will send that data back to control all of this information flow. So what this is going to do, it is going to work like an IoT based system. Now in order to do that, we need some changes in our hardware. In our hardware, we are going to replace, first of all, we will off it. If I could zoom in, yes, I will take back it. This device is based on wired connection, so we will need WPC300N. We will paste it back here and then we will on it. The same thing we will do with laptop. Second, turn it off, took it back and place WPC300N into it, turn it on, and that's all. Now you are saying these wireless network, basically this network originally has not been established yet. It is just visually showing us that okay, you have made some changes, now these are ready to establish a wireless connection with our AVAX. We will save it. Okay, now we have these devices, these wired connection here, but now how they will know that which message will be sent to which device and via which route. For that we are going to assign them IP addresses. Okay, so with the physical build complete, we move to logical configuration now, where we need an IP addressing schema that prevents conflicts. I have chosen to use class C private addresses, and we will operate on an IP address like 192.168.1.0 subnet. Okay, let's start configure it. First of all, we are going to start from here, monitor, no problem. Coming to desktop here, IP configuration. Static, we are going to assign it an IP address 168.1.2. Okay, done. So we have assigned our monitor or PC an IP address and we will write it. As I said, it is a very good practice when our projects become too complex. then these things may confuse us a lot in the long run. And we will assign it get default gateway address to 192.168.1.1. Basically, what is this default gateways and IP addressing are going to do? This will tell the computer if you need to send data to a jet in the sky, send it to the router first. Okay, 1.1 is not the IP address of this monitor. Its IP address is 192.168.1.2. Okay, but 192.168.1.1 is the IP address that we are going to assign to router. So whenever this fighter jet or this fighter jet is going to send data to coming to here on monitor, it will send that back to router. It knew that now its pathway is via router. So this will be done by our gateway address or default gateway. Now the same thing we are going to do with our server. 192.168.1.3. This is the subnet mask that we usually use 255.255.255. And we will assign a default gateway to the very same way we assigned to our monitor 168.1.1. Okay, now our work here has been done completely. Now we are going towards our router. We have a lot of things to do with it. Okay, coming here to configure, because it does not have a desktop like tab here, we assign IP addressing it via configure. So we will come here and then we will select here gigabit ethernet 0 or 0 because we have used it here, and that's why we are going to assign IP address to it. IP configuration 192.168.1.1. Okay, now you are saying that here the light has turned green. This is because we have assigned it an IP address, so it does not have any reason to stay orange. Okay, now we have done the IP tracing of our ground-based headquarters. Now we are moving towards our skyline um, devices. We will provide them IP addresses so that they could also interact and communicate with all of the remaining devices. So coming here towards AWACS, we are going to open it into its GUI. Oh my god, what is this? Well, it's nothing to be confused. First of all, I changed the internal router IP. Internal router IP, where is it? It is here. We are saying this as 192.168.0.1. Okay, we are going to change it to dot one. This is the same. It is enabled. Okay. Now, why we have assigned it to? It's because it is totally different network. The Skyline network is different. The ground-based headquarter line network is different. Both of them will communicate with each other, but both are distinct. If we assign it also one, and here as something 1.5 or 6 or else, then all of this will become only one network, which will erode the purpose of our project. Another question might arise that why we have enabled a DHCP server here. So basically the answer is that in a combat scenario, pilots usually do not have time to manually type IP addresses. Of course, they have milliseconds, seconds or milliseconds even. So DHCP allows the AWACS to automatically assign an IP to any jet that enters its range in order to ensure instant connectivity so that there remain no conflict or time wasting in doing so. Okay, then I'm going to wireless settings here and I'm going to change the name. We are going to assign it any name of our choice like Skynet Link. And okay. Then I'm coming here in wireless security and I'm using WPA2 personal and I will pass here my password like for example Rafael. I will save settings. What is happening here? Okay, let's go with Godzilla. No, we did not save these settings here. That's why I'm writing all this stuff again. Link. Okay, done. Okay, the infrastructure is ready. Now we must link the assets like fighter jet 1 here, fighter jet 2 here. So I am entering the cockpit of fighter jet 1. So I will use it and perform all work on it. Desktop here, PC wireless. Okay, now we will go here and click on connect, refresh it. Oh, what is this Skynet link? Isn't this the very same name we assigned just before? Yes, this Skynet link is basically the very same name that we have assigned for our network. Now we will connect it using our password that we assigned there, which was Godzilla. Okay, so now we are closing this screen here, and oh, here you are seeing dashes again. So basically, this is suggesting that now we have connected fighter jet 1 with our AWACS plane. And if I just came here, we could see here that it has this AWACS has assigned it this IP address 192.168.0.101. Okay, so we have changed it here because there was a fault that we hadn't saved these settings. Now we will repeat the very same thing here too with our fighter jet 2, PC wireless, connect, refresh, connect, Godzilla, connect, yes. Okay, so these dashes visualize the successful negotiation of our wireless standard. The jets are now part of the Sky network, fully connected to AWACS. But now we have to do what? I guess we have to bridge between Earth and Sky. Means we have to connect our Skyline devices with our ground-based headquarter devices like this one. So now we are going to build a link in between them, and how we will do that. Okay, now we will see that. First of all, we will establish a link between AVAX and our switch. So fast Ethernet, and now here I am going to use internet. Why internet? Because our AVAX is totally wireless, means it is just radiating its signals, its radio waves. It is not, you know, that fighter jets that are in the atmosphere, they are emitting radio waves. They communicate via radio waves, and this is the reason we are establishing and making our project an IoT based. Okay, so here internet, and we will write it down that which port we have used of this and which of this. Ethernet 0 by 4. Okay, now I have to configure AVAX, so I'm opening its setup again, and now I'm going to use static IP addressing here. Network IP address 192 168 1 and here 50. Okay, nothing else. Save settings. Oh, yeah, we have not provided its default gateway 192.168.1.1. So it has been done here. So basically this is the magic step. Why? Because this IP address belongs to the ground network. We have provided 198.168.1 to our ground network. So this effectively gives our AVAX a foot on the ground. Means that now it can take traffic from our jets, these fighter jet 1 and fighter jet 2, and then pass it down the wire to our ground router. So in this way, our Skyline network devices are communicating with our ground headquarter devices. Now a network is defined by the data it carries. So we will now simulate a real world application, also known as remote telemetry here. So for this we are going to use our server. I am editing the HTTP web browser. Make sure that both HTTP and HTTPS are on, and then we are going to edit our index.html file. So this is the code, and here we will paste another code which I'm just copying. So basically I have copied an HTML code and I'm just pasting that here, and then save and overwrite. Yes, I'm overwriting it. Okay. Okay, so now if I check and verify it, here in the URL I will paste my IP address 192.168.1.3, and here top secret level 5 Aerial Link telemetry dashboard status connected, receiving data from fighter jets. Now this display does mean that we have been succeeded in simulating a remote telemetry, that we have done our job very effectively. Okay, now let's verify the entire chain. I am on fighter jet 1, thousands of feet in the air. I open the web browser, I request the IP of the ground server. The page loads. This confirms that a packet has successfully traveled from the jet to AWACS, and then AWACS to switch, and then switch to our router, and then router to our server back. Okay, so far we have done our connectivity portion of our project. But now connectivity alone is not enough. We need to secure our data. And in order to do that, we are going to apply here SSH encryption. We will apply here via our router, because our router is insecure. So we will apply an SSH secure shell encryption to encrypt administrative access. So I'm opening here router. It's command line interface. Enable configure terminal. So now here we will name our here we will name our router name. We will enter our router name here, which is ground headquarter router. Now we will run the command enable secret and whatever here. For example, I put Rafael. So enable secret is a command, and then Rafael is the name or the secret password, whatever you put here. Now we will run the command crypto key generate RSA. Oh, sorry, we are not in configure terminal. Okay, so it is saying that please define a domain name first. So we will define a domain name first. We could assign anything. So how many bits in the module? We will write it 20, 20 10, 24. Now this command admin secret pl15. Okay, now we will run some other commands. Now you don't have to memorize these commands. These are just used to make this encryption, to make this communication an encrypted one. Okay, don't need to memorize any of these. Line vty04 transport input ssh login local and then exit. Okay, now we'll verify it. We will open our PC here in our command prompt. SSH admin 192.168.1.3 1 password. Okay, so here when I put my password pl15 and all of this stuff, it is saying that it is now on ground HQ router. When this thing comes, it means that your work has been successfully done. Otherwise it will not. For example, if I am here and I run the same command admin 192.168.1.1 and I type anything like this, it it is saying the login invalid. But when I type the right password, it is showing this thing. It means that okay, I have successfully done this work. Okay, so far we have done it incredibly, but now we have one final vulnerability, and it is that even with the SSH, a compromised fighter jet could attempt to brute force our router password. So we need to restrict that access base on location. For example, we will deploy a standard access control list. Okay, so it will make our communication more secure. So I'm typing the some other commands. So let's see what how it is going to happen here. So I open the router again. We are still in our configuration command. So we will type here access list 1 permit host 192.168.1.3 sorry 1.2, and it is like this. Then line bty04, then access class 1 in exit. Okay, now closing it, coming here, testing what we have done so far is valid or not. So ssl ssh admin dot 168.1 dot shell 15 here, and then yes, it is happening here. But if I go here in our fighter jet 1 and it try to do so, connection refused by remote host. Okay, so now we have built our secure connection that will deny all access to anyone who has not been granted that. So that's all what our project is about, and in this way we could make it, and if we could see it from simulation. Okay, so here you have seen that all these messaging has been successful. So our project is working very well. And we could verify it. Let's suppose I'm here in our command prompt. Let's see what's going to happen here. Okay, it's timeout, message sent 4, received 3, lost 1. No, because it was the first time, so it did have it usually happen. It's absolutely normal, but if I try again, 168.1.3, now you will see yes, 4 packets sent, 4 received, no loss. It means that our project is working well. So that's all, very simple and easy to make an IoT based aerial link architecture on packet tracer, and we could use our image as a background. So here you can see that a Saab made AWACS is here. This is Jet and C, the fighter aircraft, and these are ground based headquarters. Well, not precisely, but so to understand. And all of this is happening here. So that's all for now.